Here we go, section 7.4, solving polynomials. Got some nice background music here, Everly Brothers. Bring them down a little bit. We're going to do the first half of the lesson today, working with solving polynomials, what we call in factored form. That's going to become apparent what that means in just a little bit as we move forward. A little reminder here as we start going, if I multiply two things, I'm going to call my two things two variables a and b. And I know that the product of those is 0. Then I don't know what both of them are, but I know that at least one of them has to be 0. This is called the zero product principle rule. You don't need to know that name. But no, we use it a lot in the lessons that we have from chapter 7 going forward here. And just a reminder that it has to be a multiplication problem, and you have to have a 0. Okay? Oh yeah, Earth, Wind, and Fire. I love this group. Okay. Takes me back to 1970. Okay, new strategy today, people. The strategy is that to get x by itself, we need an equation to be equal to, based upon that zero product rule, a 0. This is a bad smiley face. Sorry about that cough. All right. So here we have a problem. 2 times x equals 0. Good news, we got a 0. Most of the time in today's homework, that problem is going to be 0. If it's not, we need to make it 0. All right, so option 1. I have 3 things here. So either 2 could be 0, or x could be 0, or x could be 0. Now, you might look at that and say, Mr. Larson, that can't be possibly true. 2 cannot equal 0, and you'd be right. And because we don't need to write this down twice, in this problem here, there's only one solution, and that is that x has to be 0. Okay? So in problem number 1, it is in factored form. Notice 2 times x equals 0. And so one of those 3 things has to be 0, at least. And so that gets us the answer, x equals 0. Problem 2. Negative 4 times x minus 3 has to be 0. Well, this means, again, negative 4 times x has to be 0, or x minus 3 has to be 0. Well, in this first case, x has to be 0 again, just like in that last problem. So there's one possibility. Or x minus 3 has to be 0, and for this to be true, remember we would add 3 to both sides, and so we'd get x is equal to 3. So there are our 2 answers for problem number 2. Problem 3. Again, notice it equals 0. So x plus 5 could be 0, or 2x minus 7 equals 0. Notice how we're taking both of these things that I'm multiplying and I'm setting them equal to 0. And again, we solve them both. So we're starting to get 2 answers in this problem. Well, hopefully you can see in this one it's almost a mental math problem. You add negative 5 to both sides. Bam! X equals negative 5. Or, now this is a 2-step problem back from our Algebra 1 days from the first trimester. So you add 7, so 2x equals 7, and then you divide by 2, and so you get x is equal to 7 over 2. You call it 3.5 or 7 halves. Feel free to stay in that ratio format. So here are my 2 answers. Notice how we get 2 answers frequently in our homework problems. And this will be true from now on. A couple things here to notice. Pi, okay, that's weird. And we have a power 2. Again, we don't worry because this is a multiplication problem. So I can take this piece, set it equal to 0. Now I'm not going to, there's actually 2 of those, but I'm not going to solve it twice because I'll get the same answer both times. So I'm just going to go ahead and subtract 1 or add -1 to both sides and divide by 3. So after a little bit of algebra work, I get x is equal to -1 over 3. See what I did there mentally? Again, add -1 to both sides, divide by 3. Again, don't get freaked out about pi. Pi's a number, somewhere between 3 and 4. So again, x minus pi could equal to 0. So x equals pi. All right. So a lot of the problems you're going to be doing today will be like that. Yeah. And then somebody's going to say solve by graphing. So you're going to need an automatic grapher like Desmos. You could go to your phone or your Chromebook, open up Desmos. And I've already done that. It's over here. I've typed in now the left side of that equation. Let's see how long it takes Desmos to wake up. Come on, Desmos. Guess it erased it out for me. So we're going to type in x plus 5. And then another set of parentheses, 2x minus 7 equals. Now, you could type in 0. I would suggest you type in y, and I'll explain why in a moment. It won't really matter, but I think it's better in the long term to think about that as y. Now, here's the key. Let me zoom in here, turn my projector mode on, squish the y-axis just a little bit here. Now, if you'll notice, we solved this problem already once back here in problem 3. So we know the answers. X equals -5 or x equals 7/2, aka 3.5. Yeah? And what I want to do is show you where on the graph those answers are. Uh-oh. Do you see where the graph crosses the x-axis? Do you see that point? So we can see the solutions here of -5, 0. Yeah? And then also 3.5, 0. All right, so those x-intercepts are the solutions, and they always will be the solutions. So let's write in our notes. You solve it by graphing. Again, you can say something like go to Desmos and look for x-intercepts. All right. Well, good luck in your homework. That should be enough to get you through